Hi, everybody. I'm Christe Warwick. Thank you for coming. I'm also known as Christy Wilson, which is the name that you'll see on the book that I wrote, Grokking Continuous Delivery. It took me 3 years. I don't recommend writing a book, but I do recommend having written a book. It feels pretty good now that it's done. I'm a software engineer at Google, where I've worked on a bunch of different cloud products, but the one I'm the most proud of is Tekton, which I'm actually not talking about at all. But I didn't start my career at Google. I actually worked my way there after working at a bunch of other companies for about 10 years. In fact, at my first job, I actually burnt out. It was a combination of university being pretty grueling, combined with kind of giving too much of myself to the first company and being too excited. And after that burnout, when I started at my next company, I had a lot of kind of self-doubt and some problems with confidence. But fortunately, at that new company, they actually did test-driven development. And if you haven't onboarded at a company that does test-driven development, it actually made things pretty smooth because I was able to kind of ease into things with constant feedback about what was working and what wasn't. So as a result, I came to really love tests. And around that time, that's when the original continuous delivery book came out. So continuous delivery wasn't a thing, so we wouldn't have said we were doing continuous delivery, but that is pretty much what we were doing. So I would say that for me, continuous delivery was an antidote to my burnout. Burnout reminds me of the conference theme, Halt and Catch Fire. If you didn't know what that was before you came, I'm guessing by now you probably know it refers to some illegal opcodes in an instruction set that would cause the processor to start incrementing endlessly, and incrementing endlessly is not sustainable. The only way to get out of that situation is to restart. Also, growing endlessly isn't sustainable. I'm from British Columbia, Canada, and this year we've had our worst year on record for wildfires for the amount of area burned, largely because of climate change. And I'd say that climate change is caused by unsustainable growth, by businesses trying to grow and make profits at all costs, regardless of the long-term impact. To bring it back to software, you can't just endlessly add features to software either. That's also unsustainable. There's a lot more that you have to do if you want to actually build software in a sustainable way, but we often forget because we can make a lot of progress by just tactically adding feature after feature. So unfortunately, though, if you try to sustain what's unsustainable, then you'll get burnout because you can't sustain the unsustainable. So what I want to talk to you about today is how continuous delivery can help you operate sustainably and how you can start doing it right away. But first, we have to get some kind of boring housekeeping and definitions out of the way because there's a pretty good chance that you might even be confused right now about the way I'm using the term continuous delivery because different people mean different things. So I'm not talking about continuous deployment, which I'll get to in a second. I'm talking about the practice where you keep your software in a state that it can be released at any time, and then hopefully releasing is automated as well, or at least you're doing some of the practices that get you toward that goal. If you use the term CI/CD, you're probably referring to the same thing that I mean when I say continuous delivery. So a lot of people mean continuous deployment. It does also have the initial CD after all. What's the difference between them? If continuous delivery is being able to release at any time, with continuous deployment, you're releasing automatically with every single change. So I really hope that your code base is in a state where it could be released safely at any time. So you could say that continuous delivery is a prerequisite for continuous deployment, or you could say that continuous deployment is like the extreme end of continuous delivery. While we're going through definitions, we might as well talk about continuous integration, which is the CI in CI/CD. So if you want to keep your code base in a releasable state, the way that you do that is with CI, which is the process of combining your changes together and then verifying that they actually work. If you want to combine your changes together, you need to be able to take the old version of your code and the new version and put them together. That means you have to store that all somewhere. So a prerequisite for continuous integration is version control. You absolutely need to be using version control. I would say that it is an unavoidable prerequisite. I will be pretty kind to most processes, and I will say that most people are doing some form of continuous delivery, but if you aren't using version control, I would say you're not doing continuous delivery. So if you're not using version control, you have a very easy takeaway from this talk, which is to go start using version control, because you absolutely need it. Okay, before we finish with all these definitions, just a couple more things. You can store more than just your source code in version control. I recommend putting all of your plain text data that makes up your software in there, because there's more stuff that makes up your software than just the source. There's also your deployment configuration, there's your continuous delivery pipelines, there's your policies. This is where phrases like policy as code, config as code, build as code come from. The idea is that you're treating all of this data the same way you treat your source code and using the same kinds of processes to keep it in good shape. So put all of that into version control. Lastly, you might actually be doing continuous delivery with some things that aren't software, and you might not even realize it. Pretty much any transformations that you're doing with text to turn them into some other form could benefit from some of the continuous delivery processes. For example, MLOps, which you might have heard of, is all about taking care of machine learning models, and it turns out that a lot of those processes are pretty similar to what you need to do with source code, and if you squint at the MLOps lifecycle, it looks a lot like the DevOps lifecycle. So there's actually other things you could apply it to besides just your software and your source code. Okay, so hopefully you're using version control. If you're not, you know what to do. How do you start doing continuous delivery? The very first thing to do is to get your code base into this releasable, deliverable state. I would go so far as to say, stop what you're doing and get your code base into a releasable state. It's worth stopping adding features for a little while to do this, because everything else builds on it. I'll even make an appeal to authority. Dave Farley, he's one of the authors of the original continuous delivery book. In the most recent Dora report, I think that's 2022 actually. I put 2023 in all these slides, but that's the current year, and it would have been about last year. So just have to edit that to 2022 in your head. Anyways, so he points out that as one of the people who coined the phrase, a fundamental tenet of continuous delivery is that your software is always releasable. While we're on the topic of Dora, there's a lot that we could learn from Dora that can help us with getting our software to a releasable state. So DORA stands for DevOps Research and Assessment, and they're a group that do studies where they look at what makes software teams effective. And a lot of it focuses on 4 key metrics that they use to quantify how effective a team is. These are the metrics. They go into basically 2 buckets. There are 2 of them that are about how stable your software is, and then there are 2 that are about how quickly you can get changes out. And this can be a nice lens to look at when you're trying to figure out how you can make things better with your own processes. As you might guess, they have kind of a balance with each other where changing one will affect the other ones. If your software isn't very stable, you might not want to start moving faster and deploying faster, because you might just be putting broken things out faster. That's not 100% true, which we'll talk about a bit later when we talk about deployments. But generally, what you'd want to do is focus on stability first. So get your software more stable, and then you can be free to move a bit faster. So to try to illustrate how you can get your code to a releasable state, we're going to look at an imaginary case study. This is Humblebug. It's the #1 bug watching app. The source code is stored in GitHub. The software is deployed to a Kubernetes cluster in the cloud. They do use automation for their deployments, but they have to kick it off manually. And unfortunately, they have a lot of outages, so they're pretty nervous when they have to do deployments. This is how Humblebug looks if you look at it through the DORA metrics. So they're doing really well with time to restore. Because they're using deployment automation, they can roll back really easily, but everything else is not great. Half of their deployments cause an outage. They deploy every month, but because of these outages, even that feels like maybe too much. And then because they're deploying every month, it takes about a month for changes to go from being committed to making it into production. So we're going to work on making the service more stable before we do anything else, which means doing something about that change failure rate. Let's look at one of their recent outages. So there's a recent outage where the insect list, which is one of the most popular pages for Humblebug, every time someone would load it, there was an uncaught exception. And this hit all of the users at once. So it was an outage that affected everybody. The reason that it affected everybody is because the way that Humblebug does its deployments is that they take all of their Kubernetes pods and they update them all at once. So they all switch over to the new version, which means that when this bad version went out, it hit everybody. One of the first things that they can do as they're trying to add more stability is that they can make it so that these outages don't impact as many people. So they start using canary deployments. And what this means is that instead of updating all of their pods, they'll create a new pod with the new version, direct a small amount of traffic to it, and then that way they can watch that pod, they can watch metrics that come out of it, hopefully with automation, and if things are good, then they'll roll it out to the rest of the instances. So this gives them a little bit of breathing room and reduces the pressure a bit, because even if things make it to production, at least it's just a small amount of their users. So now that they can calm down a little bit, they have to focus on getting their code base into a deliverable state. The bad thing right now is that the only way that they know their code base is deliverable is when they do a release. It's like Schrodinger's code base until they actually do the release, and then they find out that it's broken. So they want to find out earlier. And the key to that is continuous integration. So as we were talking about before, this is all about combining and verifying your changes. And what you really want to do is you want to try that the combining and the verification before things actually make it into your main branch. And this is usually called pre-merge testing or pre-merge verification. The idea is that if something has made it into your main branch, you want to be relatively confident that there's nothing wrong with it. This is something that you can do with most of your CI/CD systems. For example, in GitHub, you can add required checks so that pull requests won't merge unless they pass pre-merge validation. So if you're using a CI/CD system and it doesn't support that, you should probably switch to a new one. This is the key to getting to a deliverable state, making sure that you can get your code base deliverable and then keep it there with incrementally adding pre-merge verification. So what Humblebug is going to do is the very first thing is they're going to add a pre-merge check that makes sure that the code builds. That's it. That's the simplest place that you can start. Ideally, they would be building the software and then saving that artifact and then publishing it later, but for now, they'll just make sure that the build succeeds. So now that they have this pre-merge check, they'll know that anything in main, at least, the very least, compiles. The next thing that they're going to do is adding tests, because it's pretty much all about tests. But before they do that, they have to decide what code actually matters, because not all of the code matters equally. With legacy code bases, there's often a bunch of code that has worked for years and nobody's touched it and there's no reason to touch it. So if you don't need to touch it, don't touch it. Just leave it there, because any changes you make to it have some amount of risk anyway. Focus on the parts of your code that are actually changing regularly and start building tests around those. So the first step when you're adding these tests is to figure out what code you actually want to protect. So next, once you've identified that, Humblebug will start adding tests, and they'll add coverage checking at the same time. So what they'll do is they'll take these parts of the code that matter, add some tests to them, and then add a check that will fail any pull requests that either fail a test or that bring the coverage down. So by just making sure the coverage doesn't go down, what you get is a gradual, natural increase in tests over time. So you don't actually have to add tests for everything. You can just increase it naturally as you go. If you're starting with a fresh code base, then add all the tests, maybe set a minimum like 80% coverage or something that's reasonable, and then make sure you don't go below that. But with legacy code, you can just make sure it increases over time. So Humblebug does this. They're able to catch more of their changes before they make it to production. Looking at their change failure rate, it's now 1 in 10 deployments, so they feel a bit more confident. Now they could start looking at these other metrics if they wanted to, and they could start increasing their deployment frequency. So this is how Humblebug got into a deliverable state. First, they reduced the impact of their outages by adding canary deployments, and there's other methodologies you could use too. And then they added pre-merge testing. First, just to make sure it builds, Then they identified the parts of the code they actually care about and then started adding tests with coverage around that. So that's how you can get your code base into a deliverable state. So at this point, you might be wondering, you looked at the title of the talk, it talks about yaks. I haven't mentioned yaks at all. You might be wondering, Christy, where are the yaks? This is what I have to say about yaks. Shave them. Shave the yaks. If you're not familiar with this phrase, yak shaving is when you set out to do something and then you discover that something else is wrong that's kind of related but not directly, and then you stop what you were doing and you switch to that other thing. And that can get really comical because you could find something else that's wrong while you're doing that and so on. And then eventually what you're doing has no resemblance to what you started off doing. But here's the thing about continuous delivery. It's really great at first. The first time you set up a pipeline that runs your tests before a pull request, everybody's so happy. They say, thank you, I'm so confident in my changes now, this is wonderful. Give this person a bonus, give them a raise. But then if you fast forward, things kind of degrade over time. So you go 5 years later and your tests take 45 minutes. There are 7 flaky tests that fail every single time and nobody cares about them and they ignore them and they resent having this thing in the way of getting their code changes in. So once it gets going, you have to do yak shaving to maintain continuous delivery. And that's because fixing your continuous delivery is almost never the thing that you set out to do. Unless it's explicitly your job title, it's always tangential to the actual feature that you're trying to add. Let's take a look at what this can look like. We're going to look at one of the teams at Humblebug and how they implement some things and what happens if they don't shave the yaks as they go. So this is their backlog. You can see they have 3 features that they need to implement. So they start working on the first one. Things are going great. The pull request is nearly ready to go. And then in the code review, one of the engineers notices that it would actually be a lot cleaner if they refactored the base class that they're working with instead of just adding the changes the way they are. So they have a decision to make now. Are they going to wait to merge their pull request, go make this refactoring, or are they going to do it later? And I think this is what often ends up happening. You don't really want to stop your momentum. You want to keep going. You really want to get that thing merged. So you decide, you acknowledge that, yes, it would be better if I refactored that, but I don't want to do it right now. So if we're lucky, you make an issue in the backlog and at least write down that that should be refactored, and you're going to get to it later. So that's what the team does. They finish that feature. They move on. They're working on a new feature, but it's really strange. When they opened their pull request, there was a test that failed. It seems to be completely unrelated to what they're working on. And when they reran the tests, it passed. So are they going to look into that now? Nah, it doesn't, chances are pretty good it doesn't have to do with the changes they're making. So we'll put another item in the backlog to look into that and get our feature in. So now we're really moving. We've got 2 features implemented, 1 to go, but that's really strange. There's a set of system tests that's suddenly failing. Again, totally unrelated code. I don't think it's related to the changes that we're making here, so we're almost done. We're so close to being done. So you know what? Let's just disable those tests for now, and then we're going to get back to them later. So, okay, we finished everything. It feels so good. We finished everything. We've got all of our cleanup. We're ready. We're going to finally tackle the cleanup because we want to. We want to clean up and do the right thing. But product runs in, and unfortunately, there's a critical thing we need to implement. There's a big conference coming up, and we really need slug support, or our competitors are going to get ahead of us, so we better add some more features to the backlog. And I think that this is pretty common. I've seen this a lot. I've done this a lot. I've created a lot of lonely backlogs of code cleanup tasks that just stay there for years until somebody closes them with won't fix. But the truth is that this is technical debt. And it isn't even all of your technical debt. It's just the technical debt that you wrote down. We could put some estimates around this. So let's say that we estimate each of these, and we think that if the team had implemented them all at the time, it would have taken them about 16 extra hours to do this cleanup. So what we've actually done is that we have made a purchase with a technical debt credit card. We purchased some new features, but we didn't have all the cash to cover them, so we put some of it on our credit card. And so Humblebug now has a balance of 16 hours on their technical debt credit card. And just like a credit card, there's an interest rate. So say it was 22%. I don't actually know that I did the math right here, but just pretend that I did. So after a year, that 16 hours would increase to 20 hours if they didn't do anything. And it would keep increasing from there. Or they could pay off like 4 hours a year just to kind of maintain where they are, which I think kind of holds as an analogy, because the more technical debt you have, the slower you get over time at adding features. So your best bet, I think, is to avoid adding that debt in the first place. So for Humblebug, what that would mean is during that first pull request, they'd have to stop and do the refactoring, take another 3 hours. When that one test flaked, they'd have to stop and investigate it. We're saying it would take about 4 hours, but flaky tests are pretty intimidating, especially because it's so hard to reproduce them. Then they'd have to go and figure out why those system tests were failing and fix them. So it would take them 16 more hours, hopefully. That might even be, maybe that's even double the amount of time that they put into the tasks in their sprint. But I still think it's worth it not to carry that balance. So why wouldn't you do this? Why wouldn't you pay it off right away? I think there are 2 reasons. The first is there's genuinely an emergency. If you're fixing an outage, you don't want to go investigate a flaky test. It's worth it even if it takes you longer later because you've got bigger things to worry about. The other one is that you think you never have to pay off that balance, that you can get away with it. So what if you look at the credit card analogy, what's the scenario where you don't have to pay off the balance? Either you've died, which hopefully hasn't happened, or you've declared bankruptcy. You're basically like, I can't pay any of my debts. In software, that would mean that your project has gone under or isn't relevant anymore for some reason, so then you don't have to pay that debt. But why would you want to work on a project that you think is going to go under? So I think either you have to either pay things off later and eat that expense, or you can declare bankruptcy. And I think why not be optimistic and assume your project's going to succeed and optimize for that success and avoid racking up that huge debt that you'll have to pay later and pay the cost now. And there's an easy way, fortunately, to start paying off your debt right away, and that's to follow the Scout rule and always leave the campground cleaner than you found it. This comes from a guy who's referred to as Uncle Bob, Robert C. Martin. He wrote the Clean Code book and a bunch of other sort of classic books in software. In the book, 97 Things a Programmer Should Know, he goes on to say, I think if we've all followed this simple rule, we would see the end of the relentless deterioration of our software systems. Instead, our systems will gradually get better and better as they evolved. We would also see teams caring for the system as a whole, rather than just individuals caring for their own small part. And I like to think you could take this even further if you really wanted to. Like maybe the key to making the planet a better place would be if we all left things a little bit better than we found them. But that's beside the point. The point is to always leave your code base better than you found it. And apply this to your continuous delivery processes and pipelines as well. Shave your yaks and always leave them a little bit better than you found them. But before we stop talking about yak shaving, there's a couple things, traps that you can encounter that I want to mention. The first one is that realistically, you can't shave every single yak, especially with an older code base. There's a lot of stuff in there. If you wanted to, you can no, it's going to restart. Hold on a second. This is a yak that I did not shave while I was making this presentation. Can I make it? Sometimes it just forces a restart, which would be very sad right now. I understand. I think that's a dangerous button to hit. Okay, sorry everybody, we're gonna have to pause for a second. Okay, let's pretend that that's not happening. I'll put it on my credit card. I'll pay more for it later which is actually what's happening right now because it's in the middle of the presentation. So you can't realistically shave every yak. Especially in older code bases, there's a lot there. You get diminishing returns too. Some things are just not worth pursuing. But I think as engineers, we often fall into kind of all or nothing thinking. We think that either we have to go chase down every single yak and shave it, Or if we can't do that, we might as well not do any of it. And I think it is hard to decide what's worth pursuing and what isn't. But I also think that this is what, these are attributes of senior engineers. This is what I would look for in a senior engineer, being able to make a good call about what to pursue and what not to. And I think it's a wisdom that you can hone over time as you make this decision and see what the consequences are. And so if I encountered somebody who's doing either extreme, either doing all of the yak shaving or none of the yak shaving, I'd kind of question how senior they are. The other thing is to pay attention to who is actually doing this work. There's a lot of interesting stuff in the 2022 Dura report around burnout in general. And a couple of the things they found were that underrepresented groups were 24% more likely to have experienced burnout. And then also, they're 29% more likely to take on repetitive work. And this could just be a correlation, but in my own experience, I've at least seen anecdotally that on teams, there's often people who are in more underrepresented groups who are willing to take on some of the work that kind of has to be done in order for things to work, and maybe people in more privileged positions can kind of just afford to ignore it. Then those same people aren't rewarded for the work, and then they burn out. So pay close attention to who's actually doing that work on your teams, because it needs to be spread equally, or at least rewarded. Okay, so let's say you've got your code in a deliverable state, you're shaving a reasonable amount of yaks. At this point, you're maintaining a good state. So how can you do better than that? You can do that by bringing the pain forward. What do I mean by that? Well, what do you do when something hurts? You learn from it, because pain is information, and often the thing that you learn is to avoid it. And we do that a lot with software processes. If something takes a long time or it's unpleasant, then we do it less frequently. We avoid or hide that pain. And that's kind of like garbage. I don't like looking at garbage. It's kind of unpleasant. Unless you're a sanitation engineer, then you don't usually directly deal with it too much. You can just put it into a bin or sort it into the right bin and then empty those bins every once in a while, and it's handled for you. At least I assume that's the case in Sweden as well. I don't know if that's significantly different than Canada. And I'll get to some of the differences between Sweden and Canada. But garbage is out of sight, it's out of mind. And this is relatively recent, because it used to be common for people to just throw food or trash out of their windows into the street, at least in some European cities. It was a bad scene. It was stinky and gross. It reminds me of New York City on Garbage Day, is a lot like that. But it attracted a lot of animals and disease. Fortunately, that's not what we have now. So what happened? At least in the US and Canada, we took all the garbage and we put it in a big hole, and then we covered it up. And we solved the problem with landfills. But it's not really solved. If you look at US methane emissions, landfills are in the top 3 offenders. They're third behind burning fuel and cows, just existing, apparently, which is a whole other story. But 17% of the methane emissions come from landfills. And that's not even the whole problem, because there's other things like plastic in a landfill takes like 500 years to break down. But this isn't inevitable. And in Sweden, only less than 1% of garbage goes into landfills, apparently, whereas in US and Canada, that's most of what we do with our garbage. So putting the garbage into a hole didn't solve anything. It just hid the problem, and it created debts that need to be paid one way or another. So problems that don't have a day-to-day impact on you are pretty easy to ignore. They're out of sight. You can get away with not doing anything about them. Another appeal to authority. In the continuous delivery book, Jez Humble and Dave Farley recommend that if it hurts, do it more frequently and bring the pain forward. The idea is that if you do something unpleasant more often, you'll be more motivated to actually fix it. So let's look at a couple scenarios where we have a choice to do something about a problem or to avoid it. So back at Humblebug, you might remember that half of their deployments had an outage. So they could have, one way that you could react to this is deciding your deployments are really risky, we better not deploy very often. So let's say that they went from deploying every month to deploying every 3 months. So this is what their deployments looked like last year. They had outages in February, April, May, July, September, and October, so that's 6 out of 12, or 50% of their deployments had an outage. So what if they deployed every 3 months instead? So if their first deployment would take all the changes from January, February, and March, the changes from February had caused an outage, so that first one will have an outage. And in fact, every single one of their deployments will have at least one outage-causing change in it. So actually, they will now have an outage every single time. So they'll go from 50% to 100% of their deployments having an outage. What if instead they deployed every week and deployed more frequently? So I'm pretending every month has 4 weeks because it was easier to make this chart. So pretending there are 48 weeks in a year. You can now see at a finer grain when the outage-causing issues were introduced, and it was 8 out of these 48 weeks. So for all of these deployments, now we only have something like 17% of the deployments causing an outage. So by doing nothing but actually deploying more frequently, they've now reduced the frequency of the outages relative to the deployments. And that's because the secret about deployments are that the more changes are in the deployment, the more risk there is. If you deploy more often, you have fewer changes, so each deployment is actually less risky, and there's less chance of an outage. So what Humblebug would find is that by just deploying more frequently, they have a lower rate of outages. But now that it's happening every week, it's going to be pretty hard to ignore it. So every week they're going to be like, is this going to cause an outage? So everyone will be very motivated to get that code base into a releasable state. So let's look at one other scenario, slow tests. So when Humblebug added their pre-merge tests, they were initially pretty fast, but over time they slowed down. So now it takes about an hour for the test to run. So one way that you could react to this is you could decide, well, I don't want to block development. Let's take those tests out of the critical path, and maybe you just run them once a day instead. So now they can merge pull requests without having to worry about the test. But what happens? So several months later, we want to make a release, and a very conscientious engineer decides to check how are the tests doing, and it turns out that they're broken. And they've actually been broken for a long time because it's really easy to ignore them. In fact, there have been 52 commits by 7 different developers since they last passed, and they now take 2 hours to run. They got even slower. So then that person is now in the wonderful position of having to decide to just do the release, knowing that the tests are broken, or stop releasing and take the time to figure out which of those 52 commits caused the problem and run those tests that take 2 hours as part of debugging it. But what if instead they decided to fix the slow tests? It may have taken a long time. Let's say that for Humblebug, they had to stop feature development for 2 weeks. It took most of their developers, but they found some redundant system tests. They replaced some integration tests with unit tests. And then for the tests they couldn't change, they used sharding to make them run faster. So now they run in 10 minutes, and they were able to keep them running before each pull request. Well, now it's totally fine to do a release. There's no problem. It's also kind of hard sometimes to see the benefit, like brushing your teeth, where you don't have a cavity, so you don't really see, like, why am I doing this, because there isn't a problem. But that's what they would encounter. They'd actually be able to move faster. So if you want to improve your processes, look for the things that are painful. Look for the things that people avoid doing, but that are still really critical. These are things that you can improve easily by doing them more often, because the pain that you postpone gets worse, but the pain that you deal with every single day gets fixed or hidden in a hole. So my overall point is that it's pretty much always cheaper to deal with things now than to put them off till later. So plan for success, don't plan for bankruptcy. This is how you can add continuous delivery today. If you aren't using version control, you know what to do. And assuming you are, get your code base into a deliverable state and maintain it by adding okay, wait, at least I know what to do now. Maintain it by adding pre-merge tests, and then shave the yaks as you go. A reasonable amount of yaks, at least make things better instead of worse over time. And then make even bigger improvements by bringing the pain forward and taking the things that you're avoiding and doing them more frequently. So let's say that next week you're back at work, you're adding a feature, and something is wrong with your coverage, what do? Stop and shave the yak. Can you imagine working on a project where the code simply got better as time passed? Do you believe any other option is professional? Indeed, isn't continuous improvement an intrinsic part of professionalism? And that's all that I have for you today. If you liked that, I wrote a book. This QR code will give you 40% off the book. And I'm doing a book signing out there, and I have some free books, free copies of the book if you're interested. So thank you.